Yo, hey everybody, this is Martin, and this is part 7 of the C++ OpenGL FPS Game Engine series, where I'm following along with a Udemy course to get this framework up and running, and then the plan is to maybe build a game around that, specifically like an FPS thing. But good news, I finally finished the course, thankfully. Got to the end of it, got to the last chapter, which was all about anchors, and the last few chapters were about UI. So I'm going to go through that today. For those of you who are maybe new to this series, all it is basically me doing a bit of a devlog, going through the course, and well, now that it's finished, all I'm doing is looking through the code that I've followed along and copied, or not copied, I've written it out as I've followed along on the videos, and just picking things out and kind of figuring out what things happened, what works, and where things are put together. So it's kind of a reminder for myself to just, hey, this is how things work, rather than just me typing along blindly and not really understanding all of it. So this isn't a tutorial, it's just me following through. Link to the course is in the description, by the way, so if you're interested, check it out. Apparently there's a part 2 coming along as well, so that would be very cool. But I'm gonna focus next on actually building something out from this framework. So anyway, let's just dive in and I'll show you where we're up to and I can't remember what we actually discussed in the last video, or what I talked about in the last video, part 6. I think it was some UI stuff, but anyway, let's just show you where we're up to. But we've got UI now, and we've got a 3D world, as you've probably seen in the previous videos. We've got physics, we've got character collider, character being moved via kinematic physics, able to shoot, animation, audio. We've got a sort of bounce platform in there as well. The UI itself is very, very simple. It's just a play and quit button, as you can see right here. Just take a moment to load, and I think it's because of the screen recording, maybe. But there you go. If I click on play, we're in the game world. The frame rate definitely has to be fixed, as this is not frame rate independent. I am walking so much faster whilst I'm recording a video compared to when I'm not recording a video. So that definitely needs to be fixed. So there's a bunch of things I'm thinking about, kind of what I need to do next, and this is where the real learning begins. The real adventure is I'm going to be figuring things out now, rather than just going through a course, because the course is finished. Oh, there you go, and I've just collision tunneled right out of there. Anyway, but there you go, and I'm still falling. And I'm still falling. Yeah, and you can still shoot as well, and there you go, you still get the balls in the background. Anyway, all this is doing is just enabling and disabling the UI, and enabling and disabling the 3D world as I'm playing here. That's all. It's not scene loading. It is scene loading, but it's not scene unloading when I go back to the menu here. So that's, in my mind, one of the things that I'm going to have to tackle first early on. I've got a rough list in my head. I need to kind of put it together on notes and actually come up with, hey, this is what I want to do. Like a raycast, I've not got a raycasting API or system in there yet, so that's another thing I've got to figure out. Multiple scene loading, more complex UI, trigger bounds. Like, for example, if you go over an area, then something else loads, or a door opens, whatever it may be. There's a lot that I need to figure out from the ground up, but that's the fun part of this. So I think what I'll just go over now is, I think I'll just talk about maybe the rect transform component that got added recently. So there's a bunch of UI ones that live under the source scene components UI there. You might have seen a couple of videos ago, or last video, the button component. Everything was kind of being placed basically within the screen pixel offset. So it was like, say this bottom left is 0, 0. That's where the UI starts in this engine. And what we were doing was going 300 X and then say 500 up, and then the button would be starting here, and then the button would be drawn there based on its size. Now, it was all just relative to the bottom left corner of the screen. There was no rect transform system with a pivot and an anchor. Now that's where it kind of like began to click for me a little bit. Like, okay, yeah, rect transforms, we have these in Unity. They're basically like a I'm probably explaining this wrong, and I'm not being very articulate, but a way for children UI elements to be moved based off of the parent element. So for example, if you have the anchor of a parent element is, let's say, well, the same example, it was 300 by 500, which is here, let's say this point here with this, where this T is, then any child elements can be, if you were to say, again, another 300 by 500, they would be offset based on this anchor here. So that UI element will be up here. Now, the other cool thing about the rect transform and the canvas system as well is that when you when you resize the screen, it gets offset, it gets updated and sticks to the percentage offset that was written initially. So, sorry, this takes a moment to load, and I think again it's usually a lot faster. I think it's because of the screen recording, but I do just want to demonstrate this because this is important. Basically, the anchoring. You know, say for example, in the top right corner you have lives or health or ammo, whatever. When you resize the screen or you're dealing with different scene aspect ratios, you want that always to be in the top right corner. When you resize it to be smaller on a different screen, maybe you want the text next to it to be shifted over to the left slightly. So you can see these two here, this play and the quit button here are in the middle, and if I do this, boom, there you go. These are relative to the parent. They're not in this case, like, what is it, 1366 I think my monitor is. I've not hard coded this to be like 600 pixels from the left of the screen, you know, or anything like that. I've just said 0.5, 0.5, and the canvas is the full screen as well. So when we do this, again, just to demonstrate, boom, there you go, it's relative, which is very cool. I don't fully follow all of the code of that, but hey, let's do a little bit of a dive and see what we can find out, or what I can try and remember. But little comment for myself: rect transform is the single source of truth for UI layout, containing size, anchor, and pivot. So there we go. We've got the three vector 2s down there for size, anchor, and pivot. The anchor is what a child element would use as well for its position. Again, as I just mentioned before. So again, if you've got sort of like the main canvas, as in like the full screen canvas, bottom left is 0, 0, sort of down here. Any child element would be based off of that pivot position. I think, again, I'm not maybe being very articulate with this, and I do need to read through and understand it a little bit more. What I'll probably find is, as I'm building my own stuff, a lot of this will click into place. It will begin to make sense because I'll have to really understand it and not just follow along. I am reading and understanding and learning as I'm going, but I'm not really using it. And I think when you use it, that's when it really begins to click, you know, how things actually work. So just looking at the rect transform component, we've got load properties as well, like the same as we've had for all of the other components in here. These are all loaded from the scene file. So if I go to scene, where is my scene file? Just up there as an example. We've got a button component. I'll find the play button just to go from the top. But yeah, there we go. It's got a main canvas. It's got a canvas component. And is this the... Oh, it's not highlighting it. Oh, that is highlighting it. It's components. And then the children, yeah. So this is the canvas component is basically the root component for all UI objects, and everything under that gets rendered as a UI element component. The children that we've got, one of them is the play button, and you can see here what I was talking about before, as in it was based on the anchor of the parent. So the anchor of the parent. This is me trying to understand it in my own head. This is why I'm not very articulate. I'm kind of relearning this as I go. But the anchor is set to 0.5, 0.5 for the rect transform component, which is the parent canvas component, the root component. That means it's the center. normalized. Yeah, 0.5. It's the center of the screen, it's the center of the canvas, it's the center of the viewport that we have. So that means any child components underneath the main canvas component begin at that position on the screen. So in the middle, that's why position.x 0 places it in the middle of the screen and not the bottom left of the screen. And then all we're doing is a y offset of 50, so we're going up 50 pixels. Now that is anchored from the, how can I put it? Yeah, it's anchored from the parent component, which is the canvas in this case, and so that's why when it's resized frame to frame, we check what the new size is, and then that's why things get repositioned correctly. So you don't get the buttons going off to the left-hand side if you were to resize the screen from the left-hand side. They stay relative. I think that's right. Again, I will understand this much more as I go and I start implementing like a more, less bare bone UI. Every UI component has a rect transform component, including the root component, which is in this case is the canvas component. And again, this relates to me in my mind is how we do things in Unity. When we have at least the way I've done it in the past few years, is use the Unity UI system, which has the canvas component as like the root component, and then everything that you add to it underneath always has a rect transform component. And so that's what we're seeing here, is the play button has a rect transform component. We're setting the size of it, again, pivot, and then the anchor of that particular rect transform component as well. So if there was to be a child of this rect transform component with another rect transform component, it would use this anchor as its kind of starting position. And then I think the same for, well, a text component is separate. Text component is text, as it clearly states there. We're just using the text as play, and the font that we're defining and the size as well. I will find lots of things that I need to probably implement as I'm going and building something, which again, that's where the real learning comes in. But anyway, that's the scene file, and that's sort of where the rect transforms and the canvas component live at the bottom of that file there, and that's how they're roughly organized. If I go to the rect transform implementation again, so load properties comes from the scene file, so it's saying, hey, does it contain a size? In this case, find one. We don't have a size for the canvas component because I think it's just full screen. But there's a size there, for example. Hey, do you have a size component within this JSON? And if so, read that and apply it to the component. Let me see what else we've got. Getting the size in terms of the what we're doing when we're getting the size and we're getting the pivot and getting the anchor. That's where I'm a little bit kind of fuzzy of things. So if I go to, for example, find all references to get anchor. This is where it's kind of, I'm not very clear of what this is being used, where and how it's being used exactly. So rect transform component, get anchor, in the rect transform component. What's this one? Okay, yeah. Where is that being used? Oh yeah, that okay. I think this makes sense now. So we're still in the rect transform component. And get anchor just goes up the chain when we're trying to get the screen position. Yeah, that roughly makes sense to me. So if I need to render something on the screen at a certain position, I obviously need to know what the position is I need to render at. So we're calling get scene position. And in the case of UI, we need to go up the chain of anchors to figure out the actual position on screen. I think that's roughly what this is. So if no parent, it doesn't have an outlet, then we've got into the canvas boundary, the UI root boundary. And we're just getting the position 2D if it doesn't have a parent. So if I go to M position, and M position I think is just the actual pixel coordinates of the viewport. So, you know, if the viewport's 1280 by 800 or 720, those coordinates basically, not like a normalized 0 to 1 range, and not a 3D world range. Sorry, not a 3D world position, but just actual pixel position. But again, you have to go up the chain to know what the actual pixel position is to render at. So that's why we've got this recursively. So recursively goes up the UI chain. Have I spelled that wrong? I haven't. Recursively. I've also spelled boundary wrong as well. Yeah. Anyway. So get screen position, so you can see it's calling into itself recursively, going all the way up the chain, and then eventually getting the anchor, getting the pivot, and getting the size, so that we know the final screen position. I need to breakpoint this and just run through it to understand. Okay, yeah, right. This is how it kind of works out. So yeah, it needs to sink in a little bit more. Let's just put it that way. The other canvas component, I think this was the other one I did want to take a brief look at as well. So canvas component update, I think this, yeah, well, anything with update usually is just called every single frame. Let's just go to view call hierarchy, because I think that view is very handy. Can I slide it in there? Is it going to let me? Are you going to highlight, dude? Can I do that? I think I can. Alright, so calls to update. Searching for that. This is probably going to come from engine, is it? Engine update, maybe? Which is called from that application run, which is called from the main while loop, which sort of like is the main driver behind everything. And this is taking its sweet time. My goodness me. This is an old school laptop, guys. This is super duper old. This is a Dell Inspiron from 2014 that I'm using right now. So it is super old, and I'm one of those people that do not upgrade unless I really, really have to. I had an iPhone 5S for a long, long time, and it was only because it just eventually died that I was like, I need a new phone. And it's, yeah, unless I really, really need it, and it's my half obsession with making things run on a potato. Let's just see if we can just find our references, hey, because it's being very slow and I don't know why. Again, it could be because I'm screen recording, it could be because there's just something else going on my computer at the moment, who knows. Anyway, so canvas update. This was as the canvas is the root UI layer, set its transform to the current viewport so that the UI under is responsive. So this is what I was saying before. The canvas component being the main root UI component that drives everything below it in terms of offsets and location and so forth. Why is it giving me all of this jazz? I don't get this, guys. Like, it's update for, this is the standard template library stuff, maybe? Why has it done that? IamGUI.cpp, what? Okay, why is that popped up in here? Anyway. I don't know. I don't even think I have IamGUI in this project, which is really weird. Oh, I wonder if it's because it's a CMake project. I wonder if that's part of it. I don't know. Anyway, I'll have to figure that out at some point. I'll close that down for now, and I'll also close that one. Anyway, it doesn't matter. You get the point. Update is called every single frame from the sort of the main while loop. I'm going to have to figure out how to kind of navigate a little bit better in this. But we get the viewport size, and then we set the size if it's changed. Now this can be optimized to check if the canvas is dirty, as in the layout has changed. And then that callback from GLFW, we say, yeah, somebody's resized the canvas has been resized. Set the flag, i.e. a boolean, to say has been resized this frame. If so, then do all this, because right now this is getting called every single frame. And this is where we loop through all the child elements and render that any container UI element component. So this is, it goes down the chain, all the components recursively, and then finds, hey, we need to render this. Canvas component.init. this layout stuff, vertex layout stuff, I've not looked at in a good while. It's been a good few months. So I do need to understand this more, and it's going to come through when I come to implement things. Probably I might go over a couple of videos just to rejig my memory as well. I think flush is actually kind of gathering all the things that we do want to render. So I just go to that for a moment. Oh, solution has not finished parsing. What? What are you talking about? That is weird. Okay. Update dynamic mesh, compose the render command for UI. Yeah. So flush is basically like preparing the render command, and then once at the end of the frame, once it's gone through all of the, okay, I found all the things I need to draw, including all of the UI element components as well. Sorry, including all of the 3D world objects as well, and any 2D sprites. Then it renders them in passes. So it'll do 3D first, followed by 2D, followed by UI. And then I might have debug layer on top of that later, maybe. But there you can see get instance the engine, get the render queue, and submit. I did talk about this a good while ago. In fact, I'm sure I did like in a few videos ago. But this kind of like made it a little bit clearer for me on how this sort of pass works and what is the structure of like how a renderer works within a game engine. Is you submit commands, and then at the end of the frame, the commands all get rendered in like the passes that you want to render. So, 3D first there, boom. You might in the middle have like post-processing, or maybe after 2D you'd have post-processing perhaps, and then UI, and then maybe debug after that. So this, kind of one by one, it's all rendering those. I think that's probably about it. It's pretty late. I'm pretty tired. So I'm probably going to come back to this, and I don't know why my machine is being so slow. But the next thing that I need to think about as well is, what do I want to do next? That's the sort of big question on my mind. Is I've got a couple of ideas of where I want to take this next to kind of exercise this framework, this FPS game engine. And I'm thinking probably something along the lines of a very, very, very basic kind of puzzle first-person game. So think something like Portal, but nowhere near as complex or as cool. Just very, very, very basic. Picking up cubes, dropping cubes on buttons, moving cubes out of the way to push other cubes. Kind of puzzle elements to it. Block something with a cube in order to make the door open, those kind of things. So other games like I think I don't know how it's pronounced, Cube, Qube, a very good example. Another one would be like Manifold Garden, like not including the amazing visuals, of course, but just the, hey, put this block on here and figure out that you have to put this block on here to open this door and then progress to the next area. Because if I do that, it means that I've got to implement scene loading, which is the big thing on my mind, and scene unloading as well. I've got to get familiar with a package like Blender so that I can actually build the worlds. Then I've got to think about, okay, how do I have like a UI? Does that have to be included in every single scene file, like we've got up here? Or would it just be loaded dynamically? Probably yes, it would just be made dynamically. Like, for example, this is the game client code. So here's an example I've commented out before, but we're creating a sprite here. There was like a UI thing down here as well. Oh, they activate UI input, create a button. So this, this would be like, hey, when the game first starts, make the UI so that it doesn't have to be part of every scene, and the scene itself is just the geometry plus the movable 3D objects in the world, and everything else like UI related is brought through in this game client script here. Maybe yes, maybe no. We'll see. I am just going to click on canvas element. Where did you go? UI element component. Let's just go back. I was on canvas before, wasn't I? I don't know where it's gone to now. Ah, right there, right there. Where's the? There was an update. There was an update, isn't there? Yeah. I am just wondering why the heck this isn't. Why is it still like doing that down there? It looks like it's still indexing or something. I don't know what's going on. And find all references was just. Hey, look, I've got it there in the current project. I don't have IMGUI in the project. Why is it? I don't know. It might be one of those third-party libraries. In fact, it's finding everything in there as well, which might contain IMGUI. Maybe that's what it is. But when I go to view call hierarchy, let's just refresh that. Update calls to update. Right, there's not that many. There's only one, like from the. Oh boy, where is it called now? I can't remember where it's called from now. Yeah, sorry, I won't ramble on this video, everybody. I'll have to just restart and figure out what the heck's going on there. But yeah, next game. That's probably going to be the next video. Will maybe be a little bit of a design one and just saying, hey, these are the things I want to do. So this is the very, very basic game I want to make with this framework, with the idea that I can potentially just have it on Steam as like a free-to-play thing or whatever. Just because I do want to go through the Steam flow like myself as well. I already know it a little bit, but I do like to just kind of get more hands-on to understand that platform. Have the full game with multiple levels in, single kind of levels where you'd reach the end of a goal, kind of like at the end of Portal where there's a lift. Now, it might not have a transition to a next level. It might just be like more of a Doom thing where you reach the door and then there's a menu pop up. But multiple levels is what I'm saying. First person, puzzle elements, carrying things, moving things, buttons, trigger zones, maybe some physics in there. Nothing which is going to be like require fast reflexes or kind of time-based input. I need to have frame rate independence as well. I need to be able to change from full screen to windowed to resizing, that kind of stuff as well. Settings, yeah, there's a lot going on. Raycasting as well. There's no raycast system at all in this at the moment, so I need to figure that out. Doing a release build. Packaging, yes or no? I think it's just an exe. I believe that is all that's just wrapped up. It's all statically, what's it called? It's all static library built-in stuff. So the engine is just included in the exe. But I also have to think about assets as well. Assets, like how do they get packaged? Because I've got like textures and things up here. The assets at the moment, I mean, if I go to the output, is it view all files? Show all files is here. There's an out folder here. And this is where everything gets built. Yeah, there's the build. It's x64 debug. I don't know if I change this to non-x64 debug, that it would and then do a release build. Like what I'd usually do is I'd go through the project settings, and then actually no, there'd be a drop down here. I might need to go to manage configurations. I'll take a look at that separately. Binaries, is it binaries? Is it the what gets output? What gets output? There you go. So game development project.exe, but I've got an assets folder here. So do I package these in the assets folder? Do I package these up as like resource files and it kind of obfuscate? That's what I've got to figure out. Or do I just leave them like this and people can edit them? That's something I've got to figure out now. Using Unity, I've not looked into this for a while, but the way that it gets packaged up into a res folder, I think, and then all of the resources are just reformatted in there to non-raw asset files, so they don't have like PNGs in there or anything. It's just a resource file. That's something that can be done with C++ and Visual Studio. So I'm gonna have to figure that out and understand, like, how should this be like on the final user's machine, like a bunch of files, or just a single exe with DLLs or whatever it may be, or separate like resource files. Yeah, so you can see just with me saying that, I'm going down a fairly complex set of tasks that I need to figure out, which are usually handed to us on a plate when we use Unity. So that's where the kind of adventure is going to come in with this. So yeah, any ideas, guys? Do let me know if you think, oh, you got to think about this ABC. You've also got to consider this thing. But in terms of the game, very, very minimal, Portal style, basic puzzle platformer, art style, extremely minimal, just a white grid or a sort of very, very, very dark grey grid world like Tron is kind of what I'm thinking, and extremely simple. I'm not too bothered about the visuals, but those visuals do work as well. Like, people do like that kind of very minimalistic style. In terms of feel and tone, something quite zen-y, maybe something that's quite relaxing and easygoing. Nothing intense, you're not having lasers chasing you, or things that you've got to get done in a certain time frame. It's just a relaxing, easygoing first-person puzzle game. Boom, that's it. Anyway, let me know what you think, guys. And I'm going to do a video hopefully in the next few days. But yeah, that's it. Catch you next time. Bye.